In this video, we're going to be determining the limits of these expressions or functions if they exist, right? This is a very simple introduction into calculus, né? Very, very easy. So let's do it quickly. So the first thing you look at is the bottom, né? You have x3 minus x, right? So the question you ask yourself is this. If you substitute 2 on x, are you going to have a 0 or not? Obviously, we're going to have 3 minus 2, which is 1. Ne? As long as the bottom does not give us 0 when we substitute this guy, we can go ahead and substitute. Ne? It's easy. It's just straightforward. So we're going to say, and when you substitute, basically, you no longer write the limit, ne? Because now we have reached 2, basically. So the limit disappears because now I'm substituting 2. Ne? Sharp. So is 3, where I see x, I'm going to put 2 squared minus 4. Where I see x, I put 2 all over 3 minus 2. And then you just press a calculator, ladies and gents. Let's see, is 3, 2 squared minus 4 in bracket 2 all over 1, which is 4. So which means the limit of this expression as x approaches 2 is 4. It's like this expression approaches 4 as we get closer and closer to 2. Okay, let's do b now. So on b, we have a limit of x squared minus x minus 12 all over x minus 4, right? As x approaches 4. Remember, I said you check the bottom. Ne? If I substitute 4 here, I'm going to have 4 minus 4, which gives me 0. If you get 0 when you substitute, ladies and gents, do not substitute yet and do not rush to conclude that the limit does not exist. You have to check if you can factorize either the top or the bottom or both. Ne? So in this case, I'm seeing, okay, I cannot substitute yet because I get 0. But I see that, okay, at the top, I have a trinomial here. Ne? So I'm going to factorize that trinomial. So I have that. Then I have x minus 4 still at the bottom. And ladies and gents, my experience tells me this. One of the factors at the top will always be the same as at the bottom. Ne? So for example, here, I know that one of the factors of this trinomial is going to be x minus 4. So that this will cancel with that. Then I'm going to have x here, so that this times this gives me x squared. Ne? I need negative 12, and then I have negative 4 already. So here it must be positive 3, so that I'm going to get my negative 12. And you can see that in the middle, we need negative 1. So I'm having negative 4x when I multiply these two, and then plus 3x when I multiply those two. So negative 4x plus 3x gives me gives me negative x. You always have to verify your trinomial. Ne? Sharp. So now we can see that this cancels that. Then oh guys, sorry, I forgot to write the limit. Remember, I didn't substitute it yet. So it's limit as x approaches 4, right? Then now we have limit as x approaches 4. Remember, this will cancel with that. Then I have x plus 3 remaining, right? Then now I no longer have the bottom. If I don't have the bottom, I can simply substitute. And remember, when I substitute, the limit disappears. So where there was x, I'm going to put 4 plus 3, which gives me 7. Which means the limit of this expression as x approaches 4 is 7. It's like we're approaching 7 the more we get closer to 4. Okay, now let's do C. On C, ladies and gents, we can see that, okay, if I take this 2 and put it here, I get 6. I don't get 0. So I can easily substitute, right? Remember, as long as the bottom does not give you 0, you can substitute, okay? Perfect. So now, let's see. We are going to have equals to. Remember, the limit will disappear. So I'm going to have 3 into bracket 2 plus 1 over 3 into bracket 2. Then this gives us 6 plus 1 over 6, which simplifies to 37 over 6. Okay. Perfect. Okay. So now we're going to go to D. Ne? So on D, if we look at V, let me rewrite it here. We have limit of 1 over x as x approaches 0. Right. You check, can we substitute 0 here? We're going to have 1 over 0. And at the top, there's nothing we can do because we already have 1. So here we're going to say, therefore, limit as x approaches 0 of 1 over x does not exist. Does not exist. Then let's go to E. On E, we can see that, okay, if I take 1 and substitute here, I'm getting 2. So as long as you're not getting 0 at the bottom, you can substitute straight away. So the limit will disappear because we're now substituting 1. So I'm going to have 1 minus 1, where there was y, I put 1, over 1 plus 1, which becomes 0 over 2, which gives me 0. So our limit in this case is 0. And then for this one, for f, there's nothing I can do at the top. I cannot factorize. At the bottom, if I substitute 1 there, I basically going to have 0. So it means, therefore, this limit does not exist. Perfect. Now let's do G. So on G, we have limit as h approaches 0 of 3h plus h squared all over h, right? So here you can see, okay, if I put 0 here, I'm getting undefined, so I cannot substitute yet, but I can factorize the top because there's a common factor there. So I've been substituted, so I'm still going to put my limit as h approaches 0, then I take h out as a common factor. So here I'm left with 3 plus h all over h, right? Then I'm going, this h will cancel with that. So I have limit as h approaches 0 of 3 plus h. Now I no longer have a fraction. I'm not getting undefined. I can substitute. So it's going to be 3 plus where there was h, I'm going to put 0 because h is approaching 0. And then this becomes 3. Okay, now let's do the last two of this activity. The last two of this activity. Okay, let's check h now. On h, if I take 1 and substitute here, I get 0, right? But on h at the top, the numerator is basically perfect sum of 2 cubes, ne? So we can easily factorize that. I mean, the difference of 2 cubes. So remember, you're going to have a small bracket and a bigger bracket, right? Cube root of h cubed is h. You always take this sign, which is minus. Cube root of 1 is 1, right? And then this squared is h squared. 1 squared is 1. This times that is h, right? The sign here is always a plus. If this is a minus, this one is a plus. So this one and this one are always opposites, ne? Sharp. And then we're going to have h minus 1. Right. And then we can see that, okay, this is equals to limit as h approaches 0. This will cancel with that. So you have h squared plus h plus 1. The moment the fraction goes away, you can substitute 0 now. So here I'm going to have 0 squared plus 0 plus 1. then the answer will be 1. Perfect. Now let's do I. We have limit as x approaches 3. If you check here, if you substitute 3 here, you are not going to have an existing limit, right? So you cannot substitute as of yet because we're getting 0 at the bottom. But the exciting thing is this. The bottom is basically difference of 2 squared. Square root of x will be square root of x and square root of x. When you multiply these two, they will give you that x, right? And then remember you have plus, minus. It's going to be square root of 3 and square root of 3. Then at the top you have square root of x minus square root of 3. Then you can see that, okay, this guy will cancel with that guy. Okay, which becomes limit as x approaches 3. At the top, you're left with 1 all over square root 3. Square root x plus square root 3. Now you can substitute. You're not getting a 0 if you substitute. So you have 1 over square root 3 plus square root 3. Square root 3 plus square root 3 gives you 2 square root 3. Then that should be your final answer. And I'm sure, ladies and gents, you're realizing that the step where we're substituting this number, the limit must disappear. See, here when I substituted 0 here, I never wrote the limit, you see? So that's it about limits, ladies and gents. It's as easy as A, B, C, D. Please follow up more of our videos as we get into deeper and deeper details of calculus. But in overall, all should be simple. Please don't forget to share with family and friends and to hit the subscription button if you haven't done so yet. Thank you very much. Aluta continua.